Hey there, classes. I realize that some of you are out today when we're finishing up this section, so I thought I'd just make a couple of recordings. So that way, if you're here, you can review it. If you're not here, you can at least get some exposure to these ideas. So where we left off from the other day, we just reviewed simplifying radicals, and we started to use the Pythagorean theorem to solve for a third side, whether it's the hypotenuse or not, or the legs. Things that we need to talk about today are the converse of the Pythagorean theorem and the Pythagorean Inequalities theorem. And what these say is, well, let's say I don't know what the measures of the angles are, but if I add the sum of squares, so a squared plus b squared, if that equals c squared, and c is always the longest side of a triangle. It's a hypotenuse if it's right, but c is always the longest side. Anyway, if a squared plus b squared equals c squared, then by the converse of the Pythagorean theorem, it has to be a right triangle. What's so interesting here is that these Pythagorean inequality theorems then state, well, if c squared is greater than a and b squared, a squared plus b squared, then it's got to be obtuse. And if c squared is less than the sum of a squared and b squared, then it has to be acute. And so a nice way to put this together is with this little picture right here. And just remember, right, that the sum of any two sides of a triangle have to be greater than that third side. So on your worksheet it will say, well, is this a triangle? First you better compare the longest side, c, to the sum of the other two to make sure it is a triangle. And then once you do that, what you need to do is compare c squared, the longest side, to the sum of the other two sides squared. And that will determine whether it's a right triangle. If c is equal to a and b, it's got to be right. If c squared is greater than a and b, then it's got to be a obtuse triangle. And if c squared is less than the sum of a squared and b squared, then it has to be acute. So given these lengths, let's work this out right now. So I know that 7, 12, and 16. 16 is the largest, so I need to compare 7 and 12 to 16. So when I add those together, I get 19. So step number 1, 19 is greater than 16. Please excuse my childish looking writing. Check, yes, that's supposed to be a check mark. This is a triangle. So that's step 1. Step 2 then is to square the sides and compare them. So 7 squared plus 12 squared. Oh man, this is painful. You guys can probably have the answer by the time I'm done. And you can compare that to 16 squared. Okay? 7 squared is 49. 12 squared is 144. Oh man, that's so hard. I wish I had the writing tool. Man, that'd be great. Anyway, I don't. Do the best with what you got. 256. Boy, that is just scary looking. I'm going to switch over to typing so you guys can actually see what the heck I'm doing. All right, 49 plus 144 is 193. Okay, and I'm comparing that to 256. There we go, in case you couldn't read my writing. Well, what's greater? 193, does that equal 256? Is it less than, greater than? Well, it's less than 256. So the other way to put that is c squared, 256, is greater than, since c squared is greater than a squared and b squared, right? 193, then this has to be obtuse. Okay, and that's what you're going to do here on the worksheet. I've given you worksheets. By now, I think you should be able to finish that worksheet.